All right. So let's start with chapter 11. Couple of months ago, I said there are two sections, two chapters that are huge when you move into 162. The first one was the chapter 9 with pointers, and the second one is this chapter 11 with what we're going to call structured data type. We're going to use the word struct. And when you were doing your code listings, you saw what a struct is. But when we start talking about structs, we get into these AB abstract data types. And what it, okay, there's our words again, data types. You know, we've had data types. We had the primitive data types, int, double, bool, char. Then we learned about other data types that were created, like string was a data type that was created. And, you know, string was able to hold a value, and then string had a whole bunch of methods that went along with it. Well, when we start learning about abstract data types, it's going to follow that same kind of thought process where it can hold values and it has methods to go along with it. Sort of a little bit like a class, okay? But we're not declaring it as a class. We're looking at other ways to declare these. So the abstract data type we're going to take a look at today is called a struct. And what happens in a struct, oh, I can't even spell. What happens in a struct, which again is short for structure, is I'm able to create a new data type, and this data type holds multiple primitive or other data types. And one of the sections we talk about later is one of the things inside of a struct could be, in fact, another struct. So when we create a struct, we have to give it a name. We have to give the data type a name. And you know, I'm grabbing my book here real quick while I'm trying to talk, because in the first code listing that you typed in, and I don't have them listed, in early code listings 11.1, you had to create a struct, and then you gave it what's called a tag. And that was basically the name of the data type. You know, instead of int, I now have something called struct. So this guy is called a tag. And in naming standards, we're going to start that with a capital P. Do we have to? No. But it's good to do that. Inside of our struct, as I mentioned before, data types can hold various values as well as have methods to go along with it, or functions. I keep forgetting we're in C++, or functions. Well, we're going to look at some, and the first one is this struct, and all that's going to be inside of it is a bunch of values. And when you did code listing 11.1, the first value you had in here was int, and then you had EMP number. Okay. And then there were a couple more that went along with it, and you became familiar with it. So now I have this new data type called payroll, and just like I could say in X, I can say payroll, and then I can come up with PR, some sort of variable name that is of data type payroll. And as you went through these code listings, you started to see that if I wanted to access something, I might do the name PR followed by this field, EMP number. Okay, I would go PR, whatever the next field is, and PR, the hours, the pay rate, the gross pay. So this is a new data type that's laid out that we're going to be able to use. When we get to 162, we're going to be creating a lot of structs, but one of the things inside of the struct is actually going to be a pointer, or possibly two pointers. So as I said before, 162 is going to be a big combination of creating structures and then having some pointers inside of here to point to different memory locations. Don't worry about that now. That's something that's coming up. What's important, you know, I'm going to sort of like I instantiated an object when I did whatever it was equals new back in Java. I'm creating this new data type payroll, and I'm I'm not going to say instantiating an object. It's not, but I'm creating a variable named PR, and I'm going to do something with that. All right, so you did code listing 11.1. You typed it in and you got the basic feel for a struct. Were there any questions on that? That was basically just filling the fields and then displaying it.
What purpose do they really serve? Like, I understand how it works. I just not really understand the concept.
Okay, so if I had an array from the good old days, an array would allow me to store, this stores homogeneous data. You know what I mean by homogeneous data? It stored all test scores. It stored all names. It stored only one or two things. But back in the old days, every secretary used to have something on their desk called a Rolodex. And on a Rolodex was a card. And on that card would have been things like a name, a phone number, an address. All this different stuff would have been on each one of these cards of a Rolodex. Well, with the knowledge you have now, you would have had to create an array for name. You would have had to create an array for phone number, because these guys aren't all homogeneous. These are different. But wouldn't it be nice if I had a data type that would allow me to put all of these in one location, and then I could have an array of these structs. So structs are going to allow us to store different data types in one data type. So if you think back to the program you did on Tuesday, we wrote it and we had a name. We entered a person's name with the C string and so on. And then we entered a test score for each one. And we really didn't have a good way of saving it, did we? Well, imagine if today at the end of class, we were able to create a struct, and the struct was able to store the name, test 1, test 2, and test 3. And would it be then easy to make an array of this struct? So I would go to a subscript 1 dot name dot test 1 dot test 2 dot test 3. So it's a way for us to save, store, work with mixed data types. Does that help?
Yeah.
Yeah. So when we do that at the end of class, as you'll see, this is going to be like, that would have made that last program we worked on Tuesday a whole lot easier. Okay. 11.2 was another example of a struct. It does some stuff with a circle. You had to type that one in. Were there any questions on 11.2? I'm not hearing any. Giving initial values. I'm looking at section 11.4. There was a code listing 11.3 that you didn't have to type it in, but it was, what did I call it when I initialize something right away in the program?
We pay?
Implicit initialization. And in that code listing 11.3, you'll see employee pay equals employee 1. And then I have my set notation. I have my braces. And then I implicitly fill Betty Ross 141 goes into her employee number, and 18.75 goes into her pay rate. So I can, just like I did with an array, I can start to fill structures implicitly so that I don't have to input all that data. And Rashawn says, oh, did I say it right, Rashawn? Oh, we'll go with a yes. Okay, you typed in code listing 11.4, and 11.4 was where you actually started to see this array of structs. And again, I go back to thinking of this Rolodex, which was it was like a little wheel. Yeah, I didn't read that class, so I found that interesting. Good. A Rolodex was this little wheel that you would turn, and you could flip through alphabetically and find out a record of information about a person. Well, we're in 2020, and yeah, we got a better way to do it. Okay, so you typed in 11.4. You were dealing with an array. Are there any questions from 11.4? And again, 11.6 it briefly mentions it. And we're not going to get into it too much, but inside of a struct, you could have another struct. So if you wanted to see an example of that, you could simply go to program 11.5 and take a look at how we can put a struct inside of another struct. Okay, so as I mentioned just a little while ago, I want you to go back to the program we did the other day. And if I could get you back in your same pairs, and I do want you working in pairs or threes today, because I've been letting some people go alone, but I don't want to do that all the time. I want you to go back to that program. You're going to create a struct. STRUCT, spelling's bad today. We're going to make this structure called student. And inside of this structure, we're going to start with a string, which will be the student's name. We will have an int, and an int for the student's test 1, test 2, and test 3. Questions on that? Now, anything else you might want to put in there? Maybe, maybe not. Yeah, I'm going to let that up to you in your program. But one of the things you might want to consider is, what if I want to, fill up my struct partially and then have a spot that I can fill right away with the average so that I know what the average is. So I'm going to put question marks there because that's totally optional for you. I think we now are looking at a much nicer program than we did the other day. You can use strings. You don't have to use C strings. So you can go back to writing this the way you might normally write it. So create this structure, call it student with a capital S. Then you're going to go through and, again, you and your partner can decide, do I want double average or not? That's up to you. And then you're going to read in all the students, then display all the students, display which student had the highest score, the lowest score, and then what the overall class average is. Okay, questions? Questions? Well, let's see. I'm going to click breakout rooms, and I'm going to close all rooms and close that. And now I want to try to do breakout rooms new. All breakout rooms will close in 53 seconds. I even have a room with 2 people still working in it. I guess they're going to get kicked out. So somebody amuse me for 40 seconds. Still not snowing here, by the way.
Oh, it stopped here.
Oh, okay.
It was like a 5-minute snow.
It's
Okay.
flurrying here.
Yeah, but it's still enough that there's never supposed to be snow after tax day.
No.
So since they...
Although it's not tax day, it's not after tax day yet. It's July 15th.
Exactly. That's what I was just going to say. That, oh boy. All right. So these clowns are almost going to get kicked out. I'm curious what they were working on. I could have peeked in. Uh-oh. They panicked and saw that it was going to close. And...
Mr. Faringer?
Yeah.
Okay, just a quick question. Obviously the breakout room is closed.
Yes,
and
because I need him for my next class.
yes, just a quick question. Can I email you our thoughts anyway? Any of our work?
Yeah.
All right,
Yeah.
that's all that matters, even if you don't get graded or anything.
Yeah.
Okay, have a good day.
Yep. Thanks. See ya. Okay, it looks like we're going to go 6 breakout rooms because we have 13 people. One of the rooms is going to have 3. Okay, let me know if you have questions. And we're
Okay.
off. We're off. Here we go.